Hello friends, today we are discussing about electric potential energy. You are familiar with the term potential energy. Here, the electric potential energy means it is the energy possessed by a system of charges by virtue of their position. Suppose if we are separating the two charges at infinite distance apart, there is no interaction between these two charges as they are separate infinitely. So we can say potential energy of this system of charge is zero. It means no work is required to move one charge separate infinitely from the other charge relative to each other. And if you are bringing the charges closer together, some work should be done against the electrostatic force. You know that electrostatic force is a conservative force. So the work done by the external agent should be stored as potential energy in the system. This energy is known as electric potential energy. Let us see what is electric potential energy of a two-charge system. By definition, the electric potential energy of a system of point charge may be defined as the amount of work done in assembling the charges at their locations by bringing them in from infinity. It means if you are assembling the two charges by bringing them from infinity, some work should be done. This work is stored as potential energy of the system. Let us consider a two-point charge system. What is the potential energy of this two-point charge system? For that, suppose we have a point charge. Let us say Q1 at this point. Q1 is a positive charge placed at this point. Actually, no work is required to bring this charge Q1 from infinity to this point. Why? Because there is no electric field in this region, there is no potential in this region, so no work is required to bring the charge Q1 from infinity. If there is any electric field in this region, work should be done against this electric field. As there is no electric field, no work required to bring the charge Q1. By our definition, we have to calculate for a two system of charges. We have to calculate what is the work required to bring these two charges. That is, suppose the work required to bring Q1, we are writing as W1. But you see that W1 is equal to 0. W1 means work required to bring the charge Q1 at this location. That is equal to 0. No work is required to bring Q1 as this electric field in this region is 0. Now we want to bring the other charge Q2 at this point, which is at a distance say R12 from Q. But some work should be done to bring Q2. Why? Because there is electric field at this point. At this point, there is electric field produced by Q1. So work should be done against this electric field produced by the Q1. How can you calculate the work required to bring Q2 at this site from infinity? Work required to bring the Q2 from infinity to this point. That's equal to, we are writing as W2. That work W2 is equal to the charge into potential at that point. Potential at that point. So, what is the potential at this point? At this point, the potential is due to Q1. So we can write the work required to bring that Q2 is equal to W2 is equal to the magnitude of charge Q2 into potential at this point. At this point, the potential of Q1 is 1 by 4 pi epsilon 0 Q1 by R12. This is the expression for potential due to a point charge. 1 by 4 pi epsilon 0 Q1 by R12. R12 is the distance between the points Q1 and at this point. So, the work required to bring Q2 is 1 by 4 pi epsilon 0. Know that 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, Q1, Q2 by R12. This is the work required to bring Q2. Now we calculate what is the work required to bring Q1 and what is the work for bringing Q2, W1 and W2. Now by definition of potential energy, the total work done to assemble these charges will be stored as potential energy. That is, the total work done is equal to what? Total work done is equal to W1 plus W2 is the total work done. Okay, that is total work done is equal to W1 is equal to 0 plus W2 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12. So this is the expression for the total work done, and this total work done will be stored as potential energy. So we can write as the potential energy of the system of these two charges is 1 by 4 pi epsilon 0 Q1 Q2 by R12. This is the potential energy of the system of 2 point charges. 1 by 4 pi epsilon 0 product of the charges and by distance between the two charges. Suppose there is an external field at this location. Initially, we consider only these two charges. There is no external field. By the time potential energy is this much. Suppose we have an external field in this location, in the site of these two charges. So, while bringing the charges, work should be done against this electric field also, external electric field also. This work will also stored as potential energy of these two charges. Suppose in this location we have an external electric field E. So initially for bringing Q1 itself some work should be done because there is an electric field here. So we can write if in the external electric field, if in the external electric field, what is the work required to bring the charges? In the external electric field, we have to done some work to bring the charge Q1. That can be write as Q1 into what's Q1 into potential due to this electric field at this point. What is potential at this point due to this electric field? Suppose it is VR1. VR1. Here in this region we have a constant electric field. Suppose we have a constant electric field E in this region, and the potential due to this electric field at this point is VR1. Where R1 is the position vector of this point where Q1 is lies. R1 is the position vector of this point from the origin. Plus some work should be done to bring the charge Q2 also, and we can say the Q2 into VR2, where R2 is the position vector of the point where the charge Q2 lies. So Q2 into V actually give the work required to bring Q2 in the external field. Now this is the total work done to bring the charges in the external electric field, plus our potential energy of the system is there, so we can write as plus 1 by 4 pi epsilon 0 q1 q2 by r12. This is the total potential energy of the system of these two charges if external electric field is there. If there is no external electric field, we can simply write as potential energy of the system of charge is 1 by 4 pi epsilon 0 q1 q2 by r12 in the presence of a constant or uniform electric field in this region. We can say total potential energy of the system of charge is q1 into VR1, where V is the potential at this point q1 and V is the potential, VR2 is the potential at the point q2, where R1 and R2 are the position vector of this point q1 and q2. So qV R1 plus q2 VR2 plus 1 by 4 pi epsilon 0 q1 q2 by R12. This is the potential energy of a system of 2 point charges.